Welcome to this explainer. Today, we're diving straight into the mechanics and performance of Geowell GWSP Series oil-free scroll vacuum pumps. If you're running processes where a pristine, oil-free vacuum is absolutely non-negotiable, think semiconductor fab, mass spectrometry, or high-level research, you'll want to stick around for this one.
All right, here's our roadmap for today. We'll start with the GWSP oil-free series itself, then hit performance specifications, run through installation guidelines, cover inspection and maintenance, look at cross-industry applications, and wrap up with global service and contact info. Let's kick things off with Section 1, the GWSP oil-free series, focusing on its core identity and mechanism. Take a look at the GWSP 300. This is really the quintessential example of Geowell's single-stage, dual-sided oil-free scroll vacuum pump. The whole series spans from the compact GWSP 75 all the way up to the heavy-duty 1000, and they're all purpose-built for extremely clean gas extraction. Because of the horizontal, air-cooled design, you're entirely eliminating the risk of oil backstreaming. No oil means a perfectly pristine environment inside your vacuum chamber every single time.
Now, as we all know, when you're bringing in new hardware, compliance isn't just nice to have, it's mandatory. To guarantee safe and reliable operation anywhere in the world, these units are built to some really strict international standards. They carry CE, RoHS, and ISO certifications, so you're fully covered when it comes to environmental protection, safety, and quality management benchmarks.
So how does it actually work without oil? Well, the secret sauce is a highly precise 3-scroll plate design inside the pump head. You've got one central orbiting plate moving between two fixed scroll plates, offset by exactly 180 degrees. As it orbits, it creates these crescent-shaped compression pockets that progressively change size. Gas gets pulled into the outer pockets, compressed right toward the center, and then smoothly discharged. It's just pure, brilliant mechanical geometry doing all the heavy lifting. No friction fluids required. Moving right along to Section 2, Performance Specifications. Let's look at the empirical data and actual capabilities. When we talk about sealing and compression, the numbers really speak for themselves. The larger models in the lineup, specifically the 600, 800, and 1000, can hit a phenomenal ultimate pressure down to exactly 1 Pascal. To put that into perspective, that's about 7.5 times 10 to the negative 3 torr. Pulling down to that depth without a single drop of sealing oil, that really highlights the incredibly tight machining tolerances on those scroll plates.
Looking across the 7 different models in this series, you get a really wide band of capability. Running on a 60 Hz power supply, the pumping speeds start at 4.3 cubic meters per hour for the compact 75 model and scale all the way up to a massive 72 cubic meters per hour for the 1000. So whether you're just outfitting a small analytical benchtop instrument or you need to exhaust a massive industrial chamber, there's an optimal capacity here for sure. But what's really impressive is the operational consistency. If you map out the pumping speed against inlet pressure at 50 Hz, the performance curve is remarkably stable across the whole lineup. The curve essentially stays flat, meaning you maintain high pumping speeds even as that inlet pressure drops. In practical terms, the pump just keeps performing aggressively right up to its absolute vacuum limit.
All right, Section 3, Installation Guidelines. Let's get into the practical side, from unboxing to operation. A flawless setup starts the second the crate hits your loading dock. The standard protocol is pretty straightforward. Do a careful visual inspection to make sure there's no shipping damage. Then, take off the blank flanges, hook up a vacuum gauge to the inlet, and, this is key, do a run-in phase. You want to let the pump run for a solid 2 to 3 hours. This is your chance to verify that the ultimate pressure, the noise levels, and the operating temps match the manual, well before you ever connect it to your sensitive gear.
Now, because we're dealing with high-precision mechanics, you have to rigorously control the physical environment. These pumps are strictly for indoor use. Ambient temps need to sit comfortably between 41 and 104 degrees Fahrenheit. Keep the humidity under 85% and ensure your altitude is at or below 1,000 meters. And of course, you absolutely need a firm foundation and an atmosphere completely free of any flammable, explosive, or corrosive gases.
When it comes to system integration, it's all standard hardware. Models up to the 300 use KF25 flanges for both inlet and exhaust, while the bigger 600 to 1000 models use a larger KF40 inlet to handle the higher flow. But here is absolutely the most critical point for installation. You have to install an isolation valve between the pump and the chamber. That stops any debris from blowing back into your clean chamber when you power down. Also, make sure your inlet gas stays below 122 degrees Fahrenheit. If it's running hotter than that, you're definitely going to need to add a chiller or a cold trap.
Which brings us to Section 4, Inspection and Maintenance, ensuring life cycle reliability.
So that raises an obvious question, right? When you're supporting ultra-sensitive manufacturing or high-stakes experiments, how do you actually guarantee this pump holds its rigorous performance standards year after year, especially with zero oil to lubricate it?
The answer is a very disciplined, two-tiered maintenance protocol. Tier 1 is your daily inspection. That literally just means paying attention, listening for abnormal noise, feeling for excess vibration, basically just checking the general operational vibe. Tier 2 is periodical maintenance. Because there's no oil, the internal tip seals and bearing kits are doing all the heavy lifting, so they naturally have a prescribed life cycle. Swapping those out on schedule with Geowell's overhaul components basically resets the clock, totally restoring the pump's vacuum integrity.
Let's pivot to Section 5, Cross-Industry Applications. We'll look at where the GWSP really excels.
Because these units deliver a flawlessly clean vacuum with absolutely zero hydrocarbon contamination, they're considered critical infrastructure across a ton of fields. In mass spectrometry, for example, they prevent those annoying ghost peaks caused by oil vapor. For semiconductor manufacturing and electron microscopy, they guarantee perfect deposition and imaging environments. But you'll also see them as standard issue in medical devices, high-energy beam accelerators, and even as roughing pumps backing up high-vacuum molecular pumps.
Finally, Section 6, Global Service and Contact, how to connect with Shenyang Geowell.
Whether you need engineering support, want to order a maintenance kit, or you're looking to spec out a new system, Shenyang Geowell is super accessible. You can reach them straight at their headquarters on Chuangxin First Road over in Shenyang, China, or just shoot them an email at service@geowellscroll.com. And of course, all the deep dive specs are over on their website at www.geowellscroll.com.
To wrap things up, the GWSP series really proves that high-precision mechanical engineering can meet the absolute highest technical demands cleanly, quietly, and continuously. They hit the nail on the head when they note that this pump provides a highly effective, environmentally protective solution, especially when you can't compromise on physical footprint or absolute vacuum purity.
So, let's leave off with this. Take a hard look at your own production lines or research bays. If oil backstreaming or excessive maintenance downtime is currently holding you back, how could integrating a strictly oil-free 1 Pascal vacuum solution fundamentally transform the purity and efficiency of your own facility? Thanks for tuning into this explainer. Keep innovating, and we'll catch you on the next deep dive.